Bismillah ar-Rahman Rahim. In this session, we will discuss some numerical problems on the topic of Earth and solar system. This is a part of the syllabus of IGCSE and O level physics. And here we have the first question. Calculate the time t for light from Sun to reach Mercury if the radius of the orbit of the planet is 5.8 into 10 raised to power 10 meters. So we have given the Sun to Mercury distance, which is 5.8 into 10 raised to power 10 meters, and we have to find the time to reach the light from Sun to the Mercury. While the speed of light is given as 3 into 10 raised to power 8 meters per second, and here the Sun, the light reaches to the Mercury, which orbits the Sun, is this. So the distance between Sun and Mercury is a radial distance for the light traveling of light. So the total time that takes for travel the light from Sun to the Mercury is the radial distance divided by the speed of light. So 5.8 raised to power 10 meters divided by speed of light, 3 into 10 to the power 8 meters per second, and this meter will cancel this meter, and after simplification we have obtained 193.33 seconds, and which is equivalent to 3 minutes and 30.33 seconds. So this is question number 1. Now Pluto is another planet which is 5.9 into 10 raised to power 12 meters distance from the Sun. How long does it take light to reach Pluto? We will do the same. Here we have the distance is 5.92 from this Sun to Pluto. The distance is quite large this time, so it will take more time. So the radial distance between the Pluto and the Sun is this, and the speed of light. So we divide the distance, radial distance, by the light, by the speed of light, and here we have obtained this. So it will take 5 hours and 27 minutes, while in the above case it was 3 minutes and this. So this is quite large, and some of the tables for Sun and Earth and Moon's data is given here, which may be used in the numericals in the following topics. Name the planet in the solar system in the order of increasing distance from the Sun. So this is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So Mercury is very near to the Sun, and Neptune is very far away. So this is question number 3. Now 4. The planet orbits the Sun. Which of the following statement is false? The Sun is a star which produces its own light. It's true. The planets are seen by reflected solar light. True. The planet revolve around the Earth. No. Planet do not revolve around the Sun. Planet revolve around the Sun, not Earth. So this C statement is not correct. Venus is the planet closest to the Earth. Yes, it is true. So the statement C is incorrect. All the planets revolve around the Sun, not around the Earth. So question number 5. The Sun exerts a large gravitational force on matter. State whether the following statements are true or false. The Sun gravitational attraction keeps a planet in orbit around it. True. The force of gravity keeps the Moon in orbit around the Earth. True. The Sun contains most of the mass of the solar system. True. 99%. Sun contains around more than 99% mass of the solar system. It can be seen from table 6.12 that the planet's year's orbit time around the Sun increases with distance from the Sun. The orbital speed, however, decreases with distance. Orbital speed, however, decreases with distance. The more the distance, the less the orbital speed. Neptune travels much more slowly than Mercury, because Neptune is very far away while the Mercury is very close, so it has more attraction. The distance between the Sun and the Mercury is very close as compared to the Neptune, which is very far away. And similarly, the surface temperature decreases markedly with the distance from the Sun, with one exception, that is Venus has a high surface temperature due to its dense atmosphere of carbon dioxide acting as a heat trap. So only Venus has a high temperature 460 due to its dense atmosphere of carbon acting as a heat trap. Its very slow spin time of 243, and its spinning time is very small, very slow, extremely slow. 243 Earth days means that its days is longer than its year of 225 days. So its Earth day spin time is 243. So Earth day means that its day is longer than its year of 225. So its spinning time is more than its revolution time, which is very important. This statement is extremely important with reference to the examination point of view. The spin time is 243 Earth days, while the revolution time is 225 days. So revolution time is less than the spinning time, which is remarkable, which is noticeable here. The Mercury also has a slow spin time, 58.5 days, has practically no atmosphere, and so while its noon temperature is 350 Celsius, noon temperature is very high, and at night it falls to -170 Celsius. So Mercury, which is very close to the Sun, has a noon temperature of 350 Celsius, while at night its temperature becomes -170 Celsius. Mars is the Earth's nearest neighbor. It's coldest than the Earth. Temperature on its equator are rarely greater than 0 Celsius, even in summer. It's very cold. Mars is very cold as compared to Earth, and its summer temperature on the equator part is even rarely greater than 0. So it's always less than 0 Celsius. So it's always freezing. Its atmosphere is very thin and consists mostly of carbon dioxide with traces of water vapor and oxygen. So here traces of oxygen and water vapors are available, but in a very small quantity. So the people think that the life on Mars is there is a possibility of life on the Mars, but still it's not discovered yet. Its axis is tilted at an angle of 24 degree, so it has seasons, but these are longer than on Earth. There is no liquid water on the surface, but it has polar ice caps of water. No liquid water on the surface, but has polar ice cap of water, ice and solid carbon dioxide. These are the properties of, these are the compositions of entities that's available on this Mars. It's in some part these are large extinct volcanoes and evidence such as gorges of torrential flood in the distant past. Mars is now a comparatively inactive planet, although high winds do blow at times, causing dust storms. High wind always blow on Mars. Jupiter is by far the largest planet in the solar system, by far the largest. It has a gaseous planet and is noted for its great red spot. This Jupiter has a great red spot, which is a massive swirling storm that has been visible from Earth for over 200 years. Saturn has a spectacular ring made up of ice particles which are clearly visible through a telescope. Saturn has a spectacular ring, so they are all gaseous planet. Like Jupiter, it has an ever-changing, very turbulent atmosphere of hydrogen, helium, ammonia, and methane gas. So it's a gaseous plant like Jupiter. Uranus and Neptune are large, cold, and windy planets with small rocky cores surrounded by an icy mass of water, methane, ammonia. They both have rings and many moons. These planets have many moons. This gaseous planet, Jupiter, Saturn, Uranus and Neptune. The dwarf planet Pluto is very smaller than our moon and has an atmosphere of frozen methane and nitrogen. This Pluto is very small, so this is called a dwarf planet. Gravity and planetary motion. We know that to keep a body moving in a circular path requires a centripetal force acting toward the center of the circle. So keep a body moving in a circular path which requires a centripetal force, and in case of the planet, dwarf planet and asteroids orbiting the sun in nearly circular path, it is the force of gravity between the sun and the object that provides the necessary centripetal force. More than 99% of the total mass of the solar system is concentrated in the sun itself. So the 99% of the mass of our solar system consists of the sun itself. So it exerts a very high gravitational attraction. The strength of sun's gravitational field decreases with distance. So the farther a planet is away from the sun, the weaker the centripetal force. So this results in a lower orbital speed and longer orbital period. So if the planet is far away from the sun, its orbital speed will be slower and it will take longer time to orbit the sun. So moon is kept in a circular orbit around the earth by the force of gravity between it and the earth. So moon is kept in a circular orbit due to the force of gravity between the moon and the earth. Now test yourself, page 284 from the Hodder's education book. Tom Duncan and Heather Kennett written this book, and from the data given in table 6.1-2, calculate the circumference of the orbit of the planet Mars about the sun. The circumference of the orbit of the planet Mars about the sun is 2 pi into the radial distance. This is the radial distance in kilometers, and we multiplied with the 2 pi to get the this 1431.937 million kilometers. So this is the million kilometers is the orbital path, orbital distance from the sun, and this is the circumference of the orbit of the planet of Mars about the sun is this. The speed of the Mars in its orbit is equal to the circumference of the orbit of Mars about the sun and divide by the time of orbiting sun. So this is the circumference of orbit of the planet Mars, and now divide by the time it takes to orbit the sun. So 687 days from the table. This one is taken from here, and this is respect to the Earth Day. This is reference is this is with reference to the Earth Day. So 24 hours per day is reference of Earth it takes in a day we have 24 hours on earth. So from this we have obtained this kilometer. This day will cancel this, and this 87 multiplied by 24, and we divide this. On simplification we have obtained this kilometers per hour, 86847.22. so we divide this numerator by this denominator, and on simplification we have obtained in terms of kilometer and hours. And from the data given in tables, this 6.12 state the surface gravity on Jupiter. The surface gravity on Jupiter from the table is obtained as 23.1 newtons per kilogram. B part, the weight of an object of a mass of 50 kilogram on the surface of the Jupiter. The surface gravity is 23.9 newtons per kg. So the weight will be multiplied this mass with this gravity. We will have the weight on the Jupiter. 8. Would you expect the orbital speed of the Jupiter to be greater or less than that of Saturn? The Jupiter speed will be higher. The orbital speed of Jupiter is 1.1 million kilometers per year, while the orbital speed of Saturn is 305.32 millions per year. This orbital speed of Jupiter is higher because it is closer to the Sun as compared to the Saturn. So its speed will be slow. And we have this orbital distance and divide by the total time, and we have obtained this. Similarly for the Saturn, the radial distance multiplied by the 2 pi to get the orbital distance, circumferential distance, and divide by the time to orbit. So it takes more time, 29.5 years, and it takes 11.9 years. Its radial distance is low, its aerial distance is higher. So the orbital speed of Jupiter is greater than the Saturn. Now exam style question. The motion of the Earth and the Moon explain many natural events. State which of the following statement is not true. The Earth orbits the Sun once every 365 days. Approximately it's correct, except one leap year, which takes it approximately takes 365.125 days. So A is correct. The Moon orbits the Earth in an approximately 1 month. This is also correct. Day and nights are due to the Earth spinning on its axis is also correct. The Sun rises in the west and sets in the east in southern hemisphere. This is wrong. Sun always rises from the east and sets in the west. The statement D is incorrect. Calculate how long it takes light to travel from Sun to Mars. Take the distance of Mars from Sun to be 228 into 10 raised to power 6 kilometer, and the speed of light is 3 into 10 to power 8 meters per second. The distance of Mars from Sun is given as 228 into 10 to power 6 kilometers. So we can convert it into meters by multiplying with the 10 to power 3. So the speed of light is 3 into 10 to the power 8 meters per second. So the time taken to travel the light from the Sun to Mars is obtained as total distance, radial distance, and the speed of light. So we divide, and we have got this 12 minutes and 40 seconds, 760 seconds, and we can obtain in terms of minutes and seconds. Now, question number 3, the average distance of Mercury from the Sun is 58 million kilometers. Mercury and the Sun is this. Calculate the distance traveled by the Mercury in one orbit of the Sun. So we have to obtain the total orbiting distance, and the distance traveled by the Mercury in one orbit of the Sun is 2 pi r, and 2 pi and root 58 million kilometer, and which is obtained as 364.42 million kilometer. Now in B part, the orbital speed of the Mercury, if it takes 88 days to complete one orbit. Time to complete one orbit is 88 days, so this is 88 days into 24 hours divided by days, and we have obtained this. The total distance, orbital speed, total distance is the orbiting distance is 364.42 from the part A, and the time to complete one orbit is 88 into 24 hours. So this is 172.5 into 10 to the power 3 kilometers per hour. So orbital speed is obtained in terms of kilometer per hour is this. Question number 4, part A. When a comet enters the solar system from beyond Pluto and approaches the sun, its speed changes. State how the strength of the sun gravitational field changes as the distance from the sun increases. On approaching the comet to the sun, the dust and gas are blown backward by radiation pressure from the sun, and the comet develops a bright head and a long tail pointing away from the sun. The strength of the sun's gravitational field decreases with the distance. So the farther a planet is away from the sun, the weaker the centripetal force or force of attraction. Also, this results in a lower orbital speed and a longer orbital period. Part B, or question part 2, state how the speed of comet changes as it approaches the sun. On approaching the comet to the sun, the gravitational field strength increases, thereby speed also increases. Due to high gravitational field strength, the force of attraction will increase. The Venus is nearer to the sun than the Earth. Compare the orbital speed of the Venus with that of Earth. Explain your answer. The orbital speed of Venus, the orbital distance of the Venus around sun is this. This 108.2 million kilometers taken from the table, and the orbital time is 225 days. The orbital speed of Venus is this 108.2 million kilometers, 225, and the orbital speed of Earth is 2,149.6 million kilometers, and divided by 365 days, and we have obtained 3.0215 million kilometers per day, 2.575 million kilometers per day. The orbital speed of Venus is higher because Venus is closer to the sun as compared to Earth. The orbital speed of Venus is higher than the orbital speed of Earth because Venus is closer to the sun. Explain why Venus takes less than 1 Earth year to orbit the sun. The orbital distance of Venus is less than the Earth, therefore it completes its orbit in less time. Secondly, the force of attraction between the sun and the Venus will be higher as compared to the Earth because the distance between the sun and Venus is less as compared to the distance between sun and Earth. The Jupiter is further away from the sun than is the Earth. Compare the surface temperature of the Jupiter with that of Earth. The surface temperature of the Earth is 20 Celsius in average. The surface temperature of the Jupiter is minus 120 Celsius. Jupiter is by far the largest planet in the solar system. It is a gaseous planet and is noted for its great red spot, which is a massive swirling storm that has been visible from Earth for over 200 years. Compare the mass of the Jupiter with that of Earth. The mass of Jupiter is 1898 into 10 raised to power 24 kg, while the mass of Earth is 5.97 into 10 raised to power 24 kg. So if we divide this 10 to the power 24 may cancel out, but this is again the ratio is 318 times. This ratio is 318 times more than the mass of Earth. So the mass of Jupiter is more than 300 times the mass of the Earth, which is very, very high. Compare the orbital speed of Jupiter with that of Earth. The orbital speed of Jupiter is obtained as the orbital distance. This is Jupiter, I think, mistakenly written as Venus, but it's a Jupiter. We should replace it with the Jupiter here. It's a typing error. and this is the distance of the Jupiter and Sun is 778.6 million kilometer. Divide by the orbit time is 11.991, and whatever the given from the table, and similarly for the orbital speed of Earth, and we can compare. The orbital speed of Earth is 2.286 times the orbital speed of Jupiter, so it is quite high. The orbital speed of Earth is more than double the speed of the Venus. Oh, sorry, Jupiter. This is Jupiter. This is not Venus. This is wrong. So we should write Jupiter here. So we can write Jupiter's here. Jupiter. The speed of Jupiter is this. So now the B part, the orbital time of Mars around the Sun is 1.9 Earth years, and the orbital path is 1.5 times longer than that of Earth. Calculate the ratio of the orbital speed of Mars to the orbital speed of the Earth. So the orbital time of Mars around the Sun is equal to this, is given 1.9 times orbital time of the Earth around the Sun. So the orbital path of Mars around the Sun is this 1.5 into 10 to the power into orbital path of the Earth around the Sun. So this is the orbital time, and this is the orbital path, and the orbital path of Mars around the Sun, orbital path of the Mars around the Sun. This is orbital time of the Mars around the Sun is 1.9 into or 1.5 into orbital path of the Earth around the Sun, and divide by 1.9 into orbital time of the Earth around the Sun. So we place this in place of this. We have placed these values, and on simplification, the orbital speed of Mars is obtained as 0.789 into orbital speed of Earth. So the orbital speed of Mars is less than the orbital speed of Earth. So compare the speed of Mars. Speed of Mars is 0.789, while the speed of Earth is 1. So the ratio between speed of Mars and speed of Earth is 0.789, and speed of Earth is 1. So this is the ratio. A satellite close to the Earth at a height of about 200 km has an orbital speed of 8 km per second. Take the radius of the orbit to be approximately equal to the Earth radius of 6,400 km. Give an expression for the circumference of the orbit. The satellite height close to the Earth is 200 km. The orbital speed is 8 km per second. The radius of the orbit is 6,400 km. The circumference of the orbit, since we have been asked to take approximately equal, the radius of the orbit is taken as 6,400 kilometers, so we are taking 6,400 kilometers. The circumference of the orbit is 2 pi into radius of the orbit, which is 6,400. So this is the circumference of the orbit. State the equation of for the time for one orbit is circumference of the orbit, and divide by the orbital speed. So time it would take for orbiting for one orbit, and calculate the time it takes for the satellite to complete one orbit. Circumference of the orbit divided by the orbital speed. So the circumference of the orbit, because we are ignoring this 200 kilometer, if we take this, it becomes 6,600 kilometers. So we are ignoring it since it is given in the question. So circumference of the orbit is taken as this, and the orbital speed is 8 km per second, and this kilometer will cancel this kilometer, and we have obtained the time taken to orbit is this much second. which is around 1 hour and 24 minutes approximately. So it will take around 1.5 hours to complete an orbit. 1 hour and 24 minutes. So that's all for this section 6.1 Earth and Solar System. In the next session we'll discuss section 6.2 about the next topic,